Okay, so in the first few days of this unit, we basically spent time looking at the derivative of sine and cos. And I hinted at that you could actually go off and find the derivative of tangent and all the other trig functions. Not just tangent, but also the reciprocal trig functions of secant, cosecant, and cotangent. So that's what we're going to do today algebraically, but we are eventually just going to use the results. You should know how to do the proof of these. Okay, last day you may or may not have seen the proof of sine and cosine. It was a big, long proof. Once we know the derivative of sine and cosine, the other derivatives are much easier. So these ones I might expect you to be able to do. So that's why we'll want to pay close attention here. So the first one we're going to look at is trying to figure out what the derivative of tangent is. And we're going to use the identity of tangent to make this a much easier question. Instead of having to go off and trying to graph it or do some of the proofs like the other day, we're just going to remember that tan is sine over cos. So we're going to change the question to this and use our quotient rule to differentiate. So the derivative is going to be the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So we'll have to go through each step very carefully. So the derivative of top, since it's sine, the derivative of sine is cos. So that's the derivative of the top times the bottom, which just happens to be cos as well. And minus the bottom. So now we have cos, and the derivative of cos is negative sine. So that's the derivative of the bottom times the top, which in itself is also just sine. That's all over the bottom squared. So now we can simplify things on the top. You notice that we have a cos times a cos, so that's the same as cos squared. We could write it like this, or we could put the 2 next to the cos. We'll do that in a second. So right now we're just going to say it's cos times cos is cos squared. And on the other side, first thing I'm going to notice that I have a minus and a minus. So a minus and a minus is a plus. I'm just going to erase that so we don't think it's equals. But a negative and a negative is a plus. And then we have sine times sine, so that's going to be sine squared all over cos x squared. Now we might be tempted to cancel these coses here, cancel this and this, but we can't because the top is attached through addition. So we can't do that canceling. But we can make it look a little bit more familiar. Instead of writing cos x all squared, we're going to write it like we normally do, which is cos squared x. And then over here we have plus sine squared x all over cos squared x. Now as I was writing down that top, it started to sound familiar. Cos squared plus sine squared. I remember it more as sine squared plus cos squared, but it means the same thing. And regardless, what is sine squared plus cos squared? Well, that's equal to 1. Remember, that's identity. So sine squared plus cos squared is 1, so naturally cos squared plus sine squared, doesn't matter the order you add, it's also going to be 1. So the top of this is going to be 1 over cos squared x. And that, if you recall, is a reciprocal function. We actually have a name for this. So it's the reciprocal of cos. And this is where we got upset, and we remember the reciprocal of cos is actually secant. Not cosecant, I wish it was, but it's not. So it's secant. So it turns out with a little proof here, and that's not too difficult, just using the quotient rule, we find out that if f at x is tan x, the derivative is secant x. So it's not maybe as intuitive as some of the derivative of sine and cos, but it's not any more difficult. Oh, secant squared x, excuse me. Secant squared x. So there's one of our new our new ones that we're going to look at today. The second one we're going to look at is cotangent. Now, cotangent is the reciprocal of tan. So we're going to look at this and say, instead of doing cotangent, because I don't know what it is, but I do know now what the derivative of tan is. It's 1 over tan x. So I'm going to change it to tan so that I can do the derivative. I could leave it like this and use the quotient rule again, but I think it would be easier to use the power of a function rule and say if this is to the 1 over tan x, it's the same as to the negative 1. So I'm going to use that rule instead of doing the quotient rule on the top. Both are fine. I just think this is a little bit easier. So I haven't done calculus yet. It's all in blue. Now I'm going to differentiate. So I'm going to put y prime and change to green. Again, you'll notice I have something to the power of negative 1. So I'm just going to rush into all this, go from the outside and inside. So I don't care what that something is inside. It's to the power of negative 1. So I'm going to just do negative 1 and then subtract 1 from the exponent, which gets me a negative 2. Of course, that inside is tan x. But I can't forget that I have to now differentiate the inside. And so now it's the derivative of tan x. The good news is I just figured out that the derivative of tan x is secant squared x. So when I go here and differentiate the inside, it's secant squared x. So now I'm just going to tidy this up. The negative 1 is on the top, so is the secant squared. But this tan x to the negative 2, the negative 2 in the exponent tells me to put it on the bottom. So I'm going to have this fraction where I'm going to have a negative up at the top, that's a negative 1. The secant squared is on the top, but this on the bottom is tan x squared. So we took the negative from the exponent and put it on the bottom. I'm not going to write it like tan x all squared. I'm going to write it like we normally see it, which is tan squared x. So that technically is the answer. However, I'm sure we can simplify this. And we're going to use our rules for for trigonometry to make this look a little nicer. So I believe that this will be able to reduce down. One of our strategies, if you remember from last semester, is to, when we're trying to do trig identities, is we make them all look like sines and coses. So on the top, I'm going to change it to sine or cos, and the bottom, I'm going to change it to sine or cos. So the top is secant. Secant is the reciprocal of cosine. Or sorry, I wasn't disappointed enough. Cosine. So this is negative secant. So instead, I'm going to make it negative 1 over cosine squared. And the bottom is tan x, and we already remember already this morning that tan is sine over cos. So tan squared is sine squared over cos squared. So what I'm doing is using trig identities to try and make this question look a little easier. So converting secant into this, 1 over cos, and tan into this, produces this big fraction where I have a number on the top and a number on the bottom. When I divide fractions, I want to multiply by the reciprocal. So I'm going to convert this. I'm going to leave the top number as negative cos squared. But since I'm dividing, I'm going to multiply by the reciprocal. So this, you can imagine, comes up top, and you have to reciprocate. So it's times the reciprocal, and the reciprocal of this puts the cos on top and the sine on bottom. This is exciting because I can already see how this is going to make the question easier. Now you'll notice I'm multiplying. The inverse operation of multiplying is dividing, and I can divide a cos and a cos, a cos squared and a cos squared, and those would cancel. And I'm left with negative 1 over sine squared. that sounds awfully familiar. I've got a 1 over sine. That's a reciprocal function. And sine, the reciprocal of sine, is cosecant. Again, trying to sound disappointed because I wish it was the other way, but we remember the reciprocal of of sine is cosecant. Sorry, I forgot my squared. And notice this negative is just tagged along. So the derivative is negative cosecant squared. So what that means is if f at x is cotangent, f prime at x is negative cosecant squared x. So now I've got two of them. I've shown the proof of it. The derivative of tan, which is secant squared. And here, this is the derivative of the reciprocal, and it's the other one. It's not secant, it is cosecant squared. And it's also a negative. So just like when you have sine, the derivative is just a positive cos, and then the other one, which is cos, ends up being negative sine. The same sort of thoughts can go in to help you remember this. Tangent is a positive secant squared, and the other one is cotangent, and it's a negative cosecant squared. So what I'm going to leave for you now is for you to try and use the same process, except to figure out not just secant, but also, and you can use the exact same process. Secant is the reciprocal of cosine. So instead we can call this 1 over cos x, or change it to cos x to the negative 1. And then follow the same process here and see if you can reduce down. I'm going to tell you the answer once you're done for this. You get down to the bottom is going to be secant x tan x. So that's your goal. So it turns out the derivative of secant is secant x tan x. Second one I'd like you to try, and again follow the same procedure, is cosecant. That's the last one. Cosecant is 1 over sine x, or you imagine it as sine x to the power of negative 1. And then follow the same process. And you may or may not be able to figure or guess this, but it turns out the derivative of cosecant is negative cosecant x cotangent x. And once you write these out, you start to know some patterns. So secant, derivative of secant is secant, and then tan. And then here, the derivative of cosecant is negative cosecant, and then the opposite of tan, which is cotangent. So that's your goal. So you're going to need to fill in the blanks here. Fill in the blanks here. If you're having trouble, you can go and refer to the answer page, which is on Moodle. Or what I'll do is I'll flash it up here for a second. And maybe in a bit, after you've had a chance to try this on your own, I'll ask the supply teacher to show the next part. And you could pause on the answer. So the answer is found over here. I'll just dual screen it for a second. So you see there's the work to get secant and cosecant. And you could pause here and let people see it. But I do want you to try it on your own first. Okay, so do try it on your own first. Now, that's it for now, and you can watch the next video in a second.